We have a reasonably simple day today. We're going to be discussing polar coordinates, and so if you haven't done so already, please reference the notes. This is section 8.5 in the book. And as you can see, there's 5 problems. They're not really too bad. Go ahead and ask for these problems by Thursday's class period, these 5 problems. If we have time at the end of class, I might do one or two of them just to make it even a little bit easier. But it's section 8.5 in the book. So let's go ahead and get started with this. So we're talking about polar coordinates and graphs. And so I have made probably very minuscule references to polar coordinates. So we tend to deal with rectangular coordinates, which that's the XY plane that we're all used to, where the X value tells you how much to the right you go, and the Y value tells you how much you go, or down. And so it's also called Cartesian coordinates. That's just a fancy name for it, but mainly they are rectangular coordinates, as the book refers to it as. And so sometimes it's more beneficial to look at another coordinate system, one that doesn't necessarily abide by those spatial capacities as rectangular coordinates do. Perhaps its coordinate system works in another sort of way. And so a system that we're going to use that's very helpful to look at in many certain situations, it's polar coordinates. And the way graphing works in polar coordinates, in fact, right here underneath example 1, we can see a typical polar coordinate graph. As you can see, it kind of looks like a target. If you were shooting a bow and arrow, it kind of looks like that. And there is some reasoning for the, I guess, the structure of all of this. Virtually, what happens here is, well, the displacements from the origin represent the radius, and those various angular marks, say this mark and this mark, I believe that represents, let me make sure I say this right. It's 30 and 60 degrees. You would think that it's just, actually no, that is right. Yeah, so this is 30 degrees and the next one's 60 degrees. So then if you needed to plot 45 degrees, you'd have to place a line right in the middle. So these go in increments of, well, I guess I can't say increments of 30, but that is pretty much the spacing here. So this would be 30, would be 60, and then from 90 it would be 120 and 150. And it would go in that fashion. $210, $270 over here, so then $240 be right here. So yeah, it is increments of 30. So for example 1, we're just going to go ahead and plot some of the points that are given above, just to give an idea as to to give an idea of how to plot these things in polar coordinates. So if we were looking at point A, just 3 comma pi over 4. What this tells us, well, it tells us in order, the radius and then the angle. So we're going to plot this relative to the radius and the angle. So pi over 4, hopefully you remember that this is 45 degrees. So really for A, for the point A, with a radius of 3, so if anything, a radius of 3 tells us that we're going to be somewhere on this circle. Because notice that's radius of 1, that's a radius of 2, and then radius of 3 would be that larger circle. So notice we're graphing with respect to this circular scheme here. This is all referring to how we would plot things on a circle. That's how our system changes from our intuition of rectangular coordinates to polar coordinates. So all we have to do from here is plot with respect to pi over 4, which would be right here, which is equal to 45 degrees. And then we need to have a radius. So this would be 45 degrees. And then to have a radius of 3 means we would go out 1, 2, 3. And that point would be A. So that point would be A. We go the angular distance. So that angle tells us the distance from the terminal. It tells us the position of the terminal side of the angle. And so it doesn't say it in my notes, but I also want to add another part to this that will be a little bit more helpful with the homework. For this point, so for the first, it looks like 2 homework questions. They go on to ask, give 2 other points that correspond to this point. So it's interesting, in rectangular coordinates, 1 point, you can only have 1 point for 1 position on the XY plane. If you had an XY plane, the point right here cannot be represented by anything other than the specific rectangular coordinates of 3, 2. Nothing else can represent that point. In polar coordinates, this is not true. You can have several, in fact, an infinite number of points that could correspond to this point we drew here. One reason of this is due to the cyclic nature of the shape. Since we are viewing a system in terms of circles, which loop around and around and around, we can technically add 360. Now, I could have sworn the book says that that is cheating somewheres. Plot the point and give 2 other pairs of polar coordinates for the point. So, I mean, you could technically just keep adding 360. Again, I could have sworn it said somewhere. In fact, it goes on to say it later on, or it makes you pick an angle in between 0 and 360 degrees. So the question is, how would you be able to find, say, so how do they word it here? So the wording that they use loosely in the homework, give another polar coordinate for this point. because that point that we drew in here, that we darkened right here, can be represented by, well, we can use other polar coordinates. And in fact, we don't even have to use a coterminal angle. The reasoning behind that is we could try, I'm going to put a little A with an apostrophe, which means a different type of A. We can make a point where we change the 3 of a radius to -3. And then pi over 4, we can add 180 to it. So what's happening here is, so by adding 180 to this, or by looking at -3, it means that we're going to be going in the opposite direction relative to what the angle tells us. So let's go ahead and add 180 degrees. So pi over 4 plus 180 degrees, which is actually just, in fact, let me do that. I'll do it a little bit more concisely. Pi over 4 plus 180 degrees, which is just pi. It's going to be 5 pi over 4. This point actually lands in the same spot. And it might seem weird why that's the case, which is perfectly reasonable. So 5 pi over 4, so that's the same thing as, so what is that, 40 plus 180, 225? That's the same thing as 225 degrees. And so if we try to figure out where 225 degrees is at, it's actually going to be right here. Yeah, and so you would think to plot the point on that line, but the radius is negative, which means you go in the opposite direction. So really that's telling you, well, the negative tells you you're going to go in the opposite direction, and then you're going to plot +3 on that opposite direction, which puts you in the same exact spot. Well, maybe I should say they're congruent.
So the negative doesn't have to do with the XY plane anymore, it has to do with the direction that you go.
It's relative to the direction of the terminal side of the angle for which you construct. And so that's
So
kind
it can still be positive and under the x-axis now.
So what's that?
So like if it would have been a +3, it would have just been it could have still been under the x-axis. It would have been under the x-axis, right?
Yeah, so if that 3 would have been a positive, that would be 1, 2, 3 right there. If the 3 was positive, but since the 3 is negative, we have to go in the converse direction. So that's kind of the intricate nature of polar coordinates. And really, on the homework, I would expect, so I think the premise, it says give 2 other pairs, and one of the pairs I would want to see is definitely one where your angle is still within 0 to 360 degrees. Unfortunately, it doesn't say that in the homework. So technically, you could just keep adding 360 and finding coterminal angles, and that just defeats the whole purpose. Let's see.
And you have to find 2.
Yeah, and I noticed in the textbook answers, they find a coterminal one, and then they do one of these that I did. So I wish they would have specified a little bit more. But
I mean, is it possible to find 2 without using a coterminal?
yeah, it's impossible.
That's what I'm
You
saying.
have to use a coterminal.
Yeah, if you're finding 2, because if you can't go 180, well, you'd have to go -180, and then it would be in between 0 and 360 anyway.
Yeah, so let's format looking for answer choice B. as if answer choice B was just a regular homework question. I want to clear that out. So let's just say B was one of the homework questions. So if this were one of the homework questions, like number 13 or number 23, this is like well, similar to 13 and 23 from the homework. So this is the process I would want you to do. I'm telling you to do this. Ignore whatever the book says. One is plot. One is just plot. So you would just draw one of these graphs, exactly right here. Just draw one of these graphs for that problem. And go ahead and plot the point. So the angle tells us 270. So where's 270 at? So 270 seems to be right here. So that's 270. The -2 tells us the radius. So you would think that, all right, -2, so you go down 2, you go backwards. You have to go backwards for -2. So for -2, the line tells you the frame of reference, and then the negative tells you have to go backwards 1, 2. And that's the true point. The angle tells you the frame of reference, and the radius will tell you, well, it does tell you the radius, it really does, but it also tells you where to place that dot. Because you could technically place the dot over here, you could place it over here or over here, but it's that angle that tells you more definitively where that dot can go. So really where this red filled in point is, that is B. That is B. So that would be plotting it. That would be the first part of, say, a problem like 13 or 23 from your homework. Plot that. So 2, I would ask you to find 2 points. So really, I guess they label this as A and B and blah, blah, blah. So fine, I'll be consistent. So A, we plotted it. B, there's going to be find another polar coordinate with (0 less than or equal to theta less than 360 degrees. Find another polar coordinate such that your angle part is within 0 to 360. So this one, you cannot use coterminal. So what you would do, so we'll call that B prime. You would negate whatever the radius is. Let me just do all this in blue. So this would be another polar coordinate with the angle within 0 to 360. You would negate whatever the radius is, so -2 becomes +2. Now 270, if you add 180 degrees to that, it's going to be too much. It's going to be outside of your interval from 0 to 360. So you have to subtract 180, which would give you 90 degrees. And so that would be So if you think about that on the graph, 90 degrees, that goes straight up. And then because the radius is positive, you just go up 2. You don't have to do any of this reverse stuff. So it lands in the same exact spot. So this also lands right exactly there. I should have changed my mind. That's fine for B. You only have to find that one thing. That seems fine to me. And then C, for the homework, it goes on to say, give the rectangular coordinates. So all of these up here are polar coordinates.
That would be 0, 2, 1.
So, well, the point is not, the point, you're reading it on a polar graph, you're reading it in rectangular coordinates. What would happen if I placed the point right here? How would you read that? It gets a little bit wonky. So there's formulas that we have to utilize here. And those formulas, well, we're going to look at those formulas for now. Those formulas on the left tell you how to convert from polar to rectangular. And really, it's just a matter of really just plugging everything in. The radius is really, you're going to get the same answer really no matter what. -2 cosine of 270 degrees, -2 sine of 270 degrees. So you were right. In one of those, that was a good guess.
Well, I was thinking if that's the origin, then it's 0 because it goes straight up, and then the radius was 2, so But that was just converting straight from the radius to as x, which was still wrong. It would be wrong in other situations.
Yeah, it doesn't always happen that spatially the rectangular and the polar coordinates align in the same way, but not going to work out here.
If it's on one of the one in an increment of 90, will that happen? Will that be what happens? I don't know.
Well, let's find out. There's always there's always point C right there. So let's just do another one. Let's go on this side and do the third point over here, because we had C as well. Let's just do this problem again, but with a new point. Let's just pretend like this was your homework question. All right, first step, so let's plot the thing. I'm going to go ahead and erase all this. So here, -3 pi, if you'd like, you can go ahead and convert that to degrees. So that seems to be the negative 480. It's fine. Oh, it's 540. Oops. Oh, yeah, of course. Negative 5. So negative 540, that would put us, well, negative 540 is very large, which means it would already force us to go around one whole time. And notice, because this is a negative number, negative 540, then that means, well, really, let's go back to our instinct a little bit. We can use coterminal angles to reduce some of the redundancy of this angle.
For the part B, you would have to do, right? To make it between 0 and 360.
Well, naturally you would. So, I mean, we're gonna have to do it either way. So really, this is the same thing as negative 540 plus 360, which is negative 180. That's not good enough. We need to add another 360, which tells us that it's the same thing as negative 4, comma 180. We found the coterminal, so we didn't find another polar. Well, technically we did. I mean, really we did. We kind of answered part B in essence. But as far as if these points are the same, I don't know how that works. That gets very.
Well, it'll land on the same spot on the graph.
It lands on the same spot, but also 180 degrees and 540 degrees are not the same angle, but they land. The terminal positions land graphically on the same spot. So it comes down to how equivalence relations work under this system, which that starts to get a little bit funky, to say the least. I think this does answer part B. I really do think that this answers part B. But I'm going to pretend like, I'm just going to plot it first. Let's just plot it, because I'm rambling. So 180 degrees would bring us right here to this line. That would bring us to that line. The negative 4 would tell us we need to go 4 in the opposite direction. So that would be 1, 2, 3, 4 in the opposite direction, because the radius is negative. So this is where the point C would go.
So at this point, we could subtract 180, right? And then flip the 4, so it'd be 4, and then comma 0 degrees.
Yeah, so let's go ahead for part B. I mean, technically we answered it, but none of your homework questions have a situation like this. Their situations are more like parts A and B. So I'm going to say for part B, I'm just going to give the same premise. Give another polar coordinate. With the angle here. And so really it's a matter of, and I'll call it C, in fact, I'll do it in blue. Call it C prime. We'll make the radius positive. And then we need to figure out how to modify the angle, which you already had the right idea. We would.
It has to be less than 360, so you can't add 180.
Okay.
And it's less than or equal to 0, so you can subtract 180 to get 0.
Yeah, so 0 is inclusive, 360 is exclusive. So we'd rather subtract 180. So this is really 0 degrees. which makes sense because that would place you right here. And then it just says a radius of 4, which would bring you perfectly here. So that would answer part B. So let's test your speculation from earlier. Does this translate to 4, 0 in rectangular coordinates? So if we use those formulas, so we're using these formulas. The radius is, well, really we can use any version of this. They're all the same point in terms of converting to rectangular coordinates. So I'm just going to use 4 cosine of 0 degrees. I'll use the most recent one. Those numbers look the most simplistic. And what did you get, Blake?
4, 0.
You got 4 and 0. So it did work out. So there's a pretty good chance your quadrantals do translate very nicely. So really your rectangular coordinates, the way you would answer part C is 4, 0. So part A would be the plot, part B would be really, what's another angle once you negate the radius with the angle in that particular range?
It asks for this in the book, like this is what it's asking for in the book.
No, and I'm surprised that it doesn't.
So this is what you want.
This is what I want in the homework. This is what this is what I am looking for. Because I think it's the most helpful process. So the book says for part A, it says the same thing. For part B, that's where the book and I differ. For part B, it says just give two other polar coordinates. And I think that wording is not specific enough.
So you want one that's between.
I'd rather one specific one than 2 general ones. And the one that I'm looking for,
It's between 0.
it's an angle between 0 and 360 degrees. 0 inclusive, 360 exclusive. And then part C is the same. You shouldn't have any issues with part C. In fact, did I do all of this for the point A? I don't think I did. I think I kind of skipped around for part A. So in fact, I already answered example 2. I got ahead of myself. Example 2, it's converting all of the ones from example 1 to rectangular coordinates, but we kind of been doing that already, so I kind of jumped the gun there. But I believe I didn't do that for the point A.
Point A.
Yeah,
You wouldn't land on.
I feel like I didn't work it out in this manner for the point A. So I'm going to go back. Go backwards. Just make sure I'm explicit about this one. 3 pi over 4, which is the same thing as A. So I said this already. 345 degrees makes it a little bit easier. One plot, which would tell us 45 degrees. It's right here, and the radius would tell us that we go out 1, 2, 3. 1, 2, 3. Cool. Part B, I think I answered this already. find another polar coordinate with the angle in this interval. -3, I think we said 225, wasn't that it?
Yeah, we didn't do C.
Yeah, we didn't do C, that's it, okay. So we didn't do C. So would you like to guess where the rectangular coordinate would be for that point?
Man, I use a calculator first.
Well, by that point, you already
Yeah,
know it.
I'll take a guess at that.
Three square root of 2 over 2. Because cosine of 45 degrees is the square root of 2 over 2. Sine of 45 degrees is the square root of 2 over 2. So the rectangular coordinates, that would have been really interesting if you would have guessed that correctly. 3 root 2 over 2, comma, 3 root 2
But it
over
makes
2.
sense, you know, cosine of 45 is just, you know, you're just multiplying by 3, so you just add 3.
Yeah, you just append the 3 to the fraction. So this answer is part C.
That goes back to remembering what sines and cosines for those specific angles are.
Yeah.
And it's not too hard to do. I mean, they're basically the sine and the cosines. They're kind of reverse each other. Like they meet, but 45 degrees is the same. But like cosine of 60 is the same as sine of 30, and you know,
Right.
vice versa.
And lucky for you all, I assigned for at least the first two. Those are, in fact, almost every problem here is an odd numbered problem. And I know you all like to implore the help of the back of the book, which I don't blame you. So that should be helpful when doing these two problems. But also remember, I am asking for a specific thing for part B. I want an angle in this range. 0 to 360. I want an angle in that range for the second polar coordinate. And I'm pretty sure the back of the book does give you such a thing, but well, because there's not really much work to show with it anyways, so that should be an easy homework. All right, cool. Well, that's 40 minutes on example 1, and technically example 2 as well. So, any questions about that? So, as I mentioned, we already talked about example 2 because that was the part C from example 1. So, there's nothing really to do there. I really just see example 1.
So I'm guessing the r squared and the x squared and the y squared, would that be going from rectangular to polar?
That's right. So we'll get to that in a bit. Well, just like in example 1, we're going to do one more like it. This one we're just going to, well, I guess let's go ahead and go through all of them. So let's see. So I'm just going to go ahead. We'll call it point A. It really doesn't matter. And 5 pi over 3. Let's go ahead and figure that out. There's an angle. It's 300. So these go by increments of 30. Each one of these various sectors, that's 270, and that would be 300. 300 would be right here. So that's 300. And since we have a radius of -2, that means we go 2 in the opposite direction. 1, 2, in the opposite direction. So that's plotting the point. From here, I'm just going to go ahead and find, as I mentioned before, part B, another angle such that, or another point such that the angle lies within 0 and 360 degrees, which is really not too bad. So we can negate the radius. -2 becomes 2. And we just need to figure out whether to add 180 to 300 or subtract it to stay in that range. We're going to subtract it. So the 120, it's simply just 300 degrees minus 180. So again, this is just like problems 13 and 23. And then C says convert to rectangular coordinates. Hopefully you remember the formulas from above. I'll just rewrite them just in case. Again, those formulas are going to be available in the test. So I'm pretty open about formulas. I don't really care. So hopefully you remember what cosine and sine of 120 are, or know how to figure it out, because you don't have to derive it. Cosine of 120, you get -1/2. So then 2 times -1/2. We'll simplify that in a second. Sine is square root of 3/2, it looks like. So -1 and square root of 3. So the rectangular coordinates, -1 for x, square root of 3 for y. All right, cool. So suppose let's move on to the converse conversion from rectangular coordinates to polar coordinates. So this whole time we've been taking polar coordinates, rewriting them as rectangular ones, and we're going to go the opposite direction. Again, I'm going to make sure that I tailor example 4 to help out with, so what are the other two? So 27 and 29 and 36. 27, 29, 36, okay. This one's going to be like numbers 27, 29, and 36. So the first thing it says is plot the point in rectangular coordinates. This is kind of boring. If you get this wrong, I'm going to be kind of upset. So it's just simply plotting in rectangular coordinates.
If you plot it wrong, it's really.
If you plot it wrong, then yeah, I don't know. So that's already the first part right there. Because it says part A, plot the points in rectangular coordinates, which we just did. Check. Part B, it goes on to say, give two pairs of polar coordinates where the angle is within 0 and 360. I'm okay with that direction for a reason I will explain shortly.
So basically, you have to convert first.
Yeah, so we're going to have to convert, and that's going to be one of them. And then negating the radius is going to be the other one. So I kind of like it this way. So part B, and in fact, it says it right here as well. Find two sets of polar coordinates for the point with the angle in that interval. And we can do this.
This combines part C and part B of the last one. Pretty much.
Yeah, pretty much goes in reverse in a sense. But how does it go in reverse? We need new formulas. We need new formulas over here. These are the conversions from rectangular to polar. One of them is easier than the other. So let's do the easier one, because you might notice one of these formulas is Pythagorean's theorem, which helps you find, well, guess what? The radius. That's one of the things from polar coordinates. The other one is the direction angle. So really, and I'm going to go ahead and rewrite the formulas here. So say convert to polar first. Oops. R squared is equal to x squared plus y squared. The point that they gave us is 4, -2, which tells us that r squared is equal to 4 squared plus -2 squared. So what is that? That's 20. And r is just the square root of 20. So if anything, that's the radius. That's one part of the formula. Then the other part says that to figure out the angle, we have that tan of theta is equal to y divided by x. Y is -2 and x is 4. So really, it says that tangent is equal to -1/2. So really, one of the good things about drawing the graph and drawing it correctly is that we can sort of see what they are asking for a little bit more explicitly. Really, for the straightforward conversion, what they want to know the direction angle right here. They want to know that. And what we are able to find out using triangulation is really the reference angle. So that's why the formula is not written as, it would be misleading to write the formula as theta is equal to tan inverse of y over x. This is misleading, because the angle you get may not represent what's in red, but it may represent what's in black here. That's a huge distinction. So if anything, if we typed in tan inverse of -1/2, get about 26.57 degrees.
Which is a negative.
Which is telling us the part in black. That's telling us the reference angle in all actuality. So what we have to realize, that this gives the reference angle.
So you have to,
And you have to know how to rewrite that reference angle to put you in quadrant 4, because that's where this coordinate ends up at.
so 360 minus the 20, the reference angle, that would give you the angle that you're looking for.
Yeah, and I guess, let's see, because technically you could figure out -1 and 2 using tangent, and you could figure out the hypotenuse. Do I want to do it that way? It comes down to formatting. Yeah, that way sounds super gross. I don't like it. I forget that. Not doing it that way. So this is the way you're going to do it. So to get the angle, they tell you that tan of theta is equal to y over x, which is -2/4. We already figured out that this is tangent of -1/2. We have to remember that this, by applying tan inverse, this does not give us the final answer, but instead this gives us the reference angle. 0.57, doesn't matter. And so what we have to do with this reference angle, so they're telling us this angle right here, but we need everything else. We need everything else here. So it's just 360 minus that value. So theta is 360 minus the 26.57. So that is the true angle. So really, the rectangular coordinate, or the polar coordinate, is square root of 20 and 333.43 approximately. And to figure out the other polar coordinate, because remember it asks for 2, we can negate the radius and either add 180 to the angle or subtract 180, depending on which one keeps us in the range of 0 to 360. We're going to subtract 180 to get 153.43 degrees. I think I'm going to do a homework question right after this one. It'll just be one less homework question you have to do, just to be clear about what this process is, because it looks a little messy right here. So I'm going to do another one in a bit, but right now, does anyone have any questions? So let's see, what were the 3? 27, 29, and 36. 36 looks kind of tough. And you can't look that one up in the back. Read number 36. And this is on page 394. This is the last one from your homework. This is 1/2, comma, negative square root of 3 over 2. And it's the same directions. We're going to plot this and then find two corresponding polar coordinates for this. So this is exactly what I would expect on your homework. So plotting this is not going to be the most exact thing, because square root of 3 or negative square root of 3 over 2 is normally decimals give you a better idea of how to plot things. So 0.5 to negative 0.866. Call that right here. Right. In fact, as it will be pertinent to us later, I'm going to just write it much larger, because this will help us later on. With that one, and that two, that one. Okay, that'll be helpful later on. So that's us plotting it. Simple as that. And this is going to be good as a visual representation as well. So then two, we need to find two polar coordinates that correspond to this rectangular coordinate. So find two polar coordinates. With the angle between 0 and 360, 0 inclusive, 360 exclusive. So if anything, to figure out the radius part, that one should be much easier. Well, if you plug this in your calculator carefully, you get an exact answer. I believe so. It's 1 over 4 plus 3 over 4. That's pretty convenient. That's just 1. All right, so we found the radius. So from the radius, you can go ahead and figure out the angle. Tangent of theta is equal to y over x. Y is negative square root of 3 over 2 divided by x, which is 1/2. So be careful with this, because that's saying that this is negative square root of 3, because the 2's cancel. 2's cancel. Now, applying tan inverse on both sides does not give us the answer, but it does give us the reference angle. And we actually get a very nice reference angle. We get negative 60 degrees. So what that tells us, it tells us from this point, if we were to triangulate, then the reference angle is 60 degrees. It does not give us the final answer because the rectangular coordinate is in quadrant 4, and we need an angle that will supply us with an angle that lands in quadrant 4 as well and is within the requisite range of values. So really, we don't want negative 60, which is technically in quadrant 4. We want its coterminal equivalent. So really, the first point, which I'll call A for no particular reason, the radius is 1, and the angle that we can use, we want this angle. We want the direction angle, as it's called. It's going to be 300. 300 degrees. The 300 is coming from 360 minus 60. And if we want an equivalent point, we can negate the radius, whatever it is, and either add or subtract 180 to the angle in order to get it within the domain of 0 to 360. We can subtract, and we get 120 degrees. And that's the two answers for part B.
Honestly, that's more tangent. Like, so in the end, you're going to end up getting the tangent prime is tangent, inverse tangent of negative square root of 3, right?
What about inverse tangent of negative root 3?
So that's not really tangent. I mean, that's not really theta, that's more theta prime, right?
Yeah, you could think about it as theta prime. So that might be a good distinction to keep in mind. It doesn't really say it in the formula, but
it's actually theta prime.
It's actually theta prime. It's technically, so really the way the book words it is that it's the angle such that this is true, which means you could keep theta here and not use theta prime, but when you use the inverse, it transitions to a theta prime in the sense of how we are interpreting the answer. So yeah, that is a good way to decipher the various usages of theta going on, and as we call it, an abusive notation, which is a common thing in mathematics.
Yeah, so theta prime would be the negative 60.
That's right.
And then you just take 60 off of 360 to find theta.
Yeah, or apply that reference angle to whatever quadrant you need to be in. So
in this case, it was 360.
Yeah, in this case it was the right angle, just not the requisite domain that was asked for. But the other 4 problems are odd numbered problems, so you could probably all figure out those and convince yourself of the answers. So I'm going to end it there. Again, the final exam is 2 weeks from today. We will have a review session that Thursday before the test. It is an in-person test, so please show up. It is a 90-minute test, where I'll give you 90 minutes to take it, and we take it before Thanksgiving, so you can focus on other stuff. That's really all I have for today. Homework's due next Thursday, or this coming Thursday. It's 5 problems, just get them knocked out. We're now 4 problems.